Reflections of parent functions. Now let's discuss reflections. Reflecting the graph of f of x across the x-axis is given by negative f of x, meaning you place a negative sign in front of the original function f of x. So if our original function f of x is equal to x to the second power, and we reflect it across the x-axis, g of x becomes negative f of x, which is equal to negative x squared. Functions can also be reflected across the y-axis. And if we reflect f of x across the y-axis, it will become f of negative x. So if our original function is f of x, which is equal to the quantity x minus 2 raised to the second power, we would reflect it across the y-axis, and the original x value would be replaced by a negative x value. So we would have negative x minus 2 squared will produce this blue graph. Now some of you may be wondering or thinking, wait a second, h of x is also equal to the quantity x plus 2 raised to the second power, because the vertex is at negative 2, 0. And this is occurring because when you flip the graph of x minus 2 raised to the second power over the y-axis, you'll get the same graph that could have also been found by translating an original function, like the parent function, I should say, x squared. If we started off with x squared, you could also get this blue graph by translating this green one 2 units to the left, which is x plus 2 quantity squared. Therefore, there are 2 ways to write this h of x function. You could write it as negative x minus 2, that whole thing in parentheses raised to the second power, or you could write it as the quantity x plus 2 raised to the second power. Another way to show that negative x minus 2 squared is equivalent to x plus 2 quantity squared would be to factor out a negative 1 between both of these two terms. It is still inside the first set of parentheses, and when we do that, we get negative 1 outside times x plus 2, and then the entire thing squared. And remember, through the property of exponents, you need to distribute that square to both terms. So you would end up having negative 1 quantity squared times x plus 2 squared. And then negative 1 squared is positive 1. So we are then left with this exact function, h of x is equal to x plus 2 quantity squared. Now let's try some examples with reflections. We'll begin with this one. Let f of x be equal to negative of the quantity x minus 3 squared plus 9. Its graph is shown to the right in black. Graph the new function in the same coordinate plane and describe the transformation that occurs. So the first one that we have is that g of x is equal to f of negative x. Since the negative sign is inside of the parentheses with the x, we are going to replace the x in our original f function with negative x. So we have that g of x is equal to negative, and then we have negative x minus 3 squared plus 9. Now, both of our terms inside of these parentheses are negative, so we can factor that negative 1 out, but not fully out of this set of parentheses. It's just among these two terms. So I'm going to make the outer parentheses a square bracket now, and we're bringing a negative 1 out. And then when we do that, we will have x plus 3. And this whole thing is squared, plus 9. Now remember, when you have two terms being multiplied and there's an exponent outside, you need to distribute that exponent to both terms inside of the brackets or parentheses. So we still have negative that's way out in front from our original function. And then we have -1 quantity squared times x plus 3 squared. And then we have a plus 9. Well, -1 squared is +1. So we still have the negative that's out in front there. But -1 squared again is +1. So we don't have to write it. And we have x plus 3 remaining squared plus 9. That tells me that my parabola is going to open downward and its vertex is going to be -3, +9. So let's actually graph this. So at -3, it's right here. +9 is even with this one. So this will be g of x, and then it goes down 1 over 1 in both directions. And then the next one will be right about here. So this is what our g of x function looks like. And now describe the transformation that occurs. We reflected f of x across the y-axis. So that's the final answer in words for part A, and the graph that we drew is of the function g of x. And here's our g of x graph, and it does match the graph that we drew, and it does represent a reflection over the y-axis, as we found. Now let's look at part B, h of x, which is equal to negative f of x. So this negative out in front goes to everything in f of x. So we have negative of, and I'm going to put the whole thing in big brackets, negative x minus 3 squared plus 9. So there are two terms in this set. We have this first one right here, and we have this term right here. So we need to take this negative that is out in front, and we need to distribute it to both terms because there's this hidden -1. So we're going to take the -1 and distribute it to both terms. And when we do so, our first term, the negative of x minus 3 squared, will become positive x minus 3 squared. And then when we multiply -1 times +9, we will get -9. So our parabola will now open upward. So it'll kind of look like this. And its vertex is going to be 3, -9. So here we're at 3, and if we go down 9, this is going to be where our vertex is. And now we can graph our new parabola. So this is h of x. And now we need to describe the transformation that occurred between f of x and h of x. Well, it reflected across the x-axis. And here's the solution for h of x, which is equal to negative f of x. It is a reflection over the x-axis, and the graph shown matches the graph that we drew. Here's another example. This time we're going to let f of x be x to the third power, or a cubic. Its graph is shown to the right. Graph the new function in the same coordinate plane and describe the transformations that occur. So the first one that we're going to do is j of x, which is equal to negative of x minus 1, that quantity cubed. So right away, instead of just being x cubed, we have an x minus 1. So it's resembling that x minus h. And because it's a cubic, we're raising it to the third power. So that h value is a translation or a horizontal shift to the right 1 unit. And then after we shift our original function to the right 1 unit, and I'm using my center point to be my first point that I move. And then this negative out in front here is a -1, so we're going to reflect it across the x-axis because this negative sign is out in front of the whole thing. So followed by a reflection across the x-axis. So that's not going to change our center point because that's on the x-axis. But instead of this point after the translation being over here, it's going to end up being down here. And this one, instead of being here after the translation, it's going to be up here. So our function, after both transformations occur, will look something like this. So this is our j of x function. Okay, so we graphed it in the coordinate plane and we did the descriptions. And here's the graph of j of x, and it does match the graph that we came up with, as well as the description of the transformations that occurred. A horizontal shift to the right 1 unit, followed by a reflection over the x-axis. So now let's look at question B. K of x is equal to f of -x plus 1. So if our original function f of x is x to the third, we're going to substitute -x in for x and then add 1 to the end of it. So that's going to be -x to the third and then plus 1. Now if we evaluate this, we have this hidden -1 in front. We're going to distribute this third power again to both terms inside of the parentheses. So that's going to be -1 to the third times x to the third. We still have the plus 1 at the end. -1 to the third power is -1. So we can just keep a negative sign out there. You could put the 1 there if you would like, but you don't have to. And then we can carry down the x to the third power and then bring the plus 1 in. So our algebraic function for k of x will be -x cubed plus 1. When we graph this function, our original starting point is the origin before it goes up and down on both sides. When we do this reflection, it's occurring over the y-axis, so we're flipping it this way, and we're flipping this side this way. So it would look something like this, but then we also have to translate it up 1 unit. So our final function will have this shape, but it will be centered about the point 0, 1. So this is our function k of x. And now let's describe the transformations that occurred. We had a reflection over the y-axis, followed by a vertical shift up 1 unit. And here's the solution to the second part of our example. And it does show that k of x was the function f of x that reflected across the y-axis, followed by a vertical shift up 1 unit.